Hi there. Welcome back to C++ Programming Fundamentals. We are talking about basic structures of basic structure, let me clarify that, of the language in our fundamentals. And we're going to take a look, first of all, at fundamental types in the C++ language. We won't spend a lot of time on these because we're going to see some of them in much more detail as we get into definitions and declarations and other parts of the language. But I just want you to know that they are there, and this will be mostly a recap of things that you've already learned in C and other languages. We have booleans, characters, integers, floating point variables, voids, enums or enumerated variables, and then classes which create new types that we define on our own. We kind of list those at the end because it's not really a fundamental type, but you will be creating with enum and your own classes, you will be creating new types which will behave exactly the same as the bools, chars, ints, and all of the other fundamental types. So we at least want to mention that here. Now here's our first set of fundamentals, and these are called integral types. That's the Boolean, character, and integer types. Boolean is either true or false. It's a 1 or 0 value if you wanted to look at it inside the machine. And here we create a Boolean variable called var, and then we set it equal to the result of A compared to B. That's our equality operator there, the double equals. If A is equal to B, and those are obviously previously defined variables. If A is equal to B, then a 1 or true value would be set into var, and if they are not, then false or 0 would be implemented, initialized into var. Characters, we have the same character setup that we used to have in C, and they're a char var equal to a constant, quote a quote for lowercase a, and so on. They work exactly the way as they did in C, and we also, of course, have unsigned characters if you need them to hold a larger value. We have integers, and again the same way. We have short ints, we have long ints, we have normal ints, and we have signed and unsigned of all of those. They default to signed, so you don't have to use the word signed, so that they can hold less than 0 values, and you can use the keyword unsigned if you want to make unsigned integers which carry 0 or positive values only. It's really only recommended to use unsigned integers if you want to create a bit field so that you can set and reset various bits in the byte. It doesn't make any sense anymore to use unsigns to try to just hold larger numbers, and normally type casting and shifting will mess you up anyway. If you're trying to have only positive values in something, you're going to get caught in typecasting, and it's not going to do what you want to do. Here's our floating point fundamental types, float, double, and long double. They're initialized just the way they used to be. No big deal, 1, 2, 3, 4. We can have floating point values in all of those. And now here's an interesting one, the enumerated or enum. Now here we make a new type. This is going to be a brand new type. It's going to be like an integer or a character or one of the base types that's in the language. We use enum. And here we're going to create something called a number word. And number word will be equal to 0, 1, or 2, these values. And that's exactly what it does. It assigns 0 to the first one, a 1 to the next one, 2 to the next one. So these words will be, in our case here, they will happen to represent the numbers that are assigned to them. So here we make a new variable. It is of type number word. So where you would put int or something like that, we use our enum. It's an enumerated type. We made a new type, number word variable, and we can set it equal to 0. We have to use one of the words that the identifiers up here that we used when we created this enum. Okay, so we can set variable equal to 0, and then we can test it based on that. So we can say if this variable equals 1, again one of those words, then we'll go and do something as a result of our if. So that's an enum. There are some other fundamental types. There's a void, and a void is never used by itself because it isn't anything. It's the representation of nothing. So we can have void type pointers. We can have functions that take void input, which means no input. We have void return functions, which are not allowed to provide any return, and that basically tells the compiler nothing should ever be here. This is a void, but the word void is never used by itself. We still have pointers, and pointers are of the correct size in your computer to contain the address of something else. All right, that's going to be a pointer to another object or another item in the language, a variable or a class or something like that. An array is a grouping of all the same things. A group of integers, a group of classes. We can have an array of classes. We can have an array of structures, all sorts of things like that. But it is a grouping of all the same thing. A reference, we're going to see references in detail, but it refers to another thing, another object, without being that object. You never actually modify a reference. If you increment it, you are actually incrementing the thing that it refers to. If you take an address of it, it doesn't exist in memory, so you get the address of what it points to as a reference, and we'll see what those are and how to use them later. And then we have structures and classes, which are, again, fundamental types that we create when we create new classes and new data structures of other kinds of items put together, other kinds of variables and other smaller fundamental types. So that's our fundamental types in our C++ fundamentals. So let's move on to the next video. Thanks for watching.